Thank you. And congratulations on the 600. That's quite an amazing achievement. And this is a remarkable place to be. And it's a remarkable place to be to talk about the future as well. But it's a little bit difficult to talk about the future because we tend to get it wrong. So I'm a little bit reluctant about talking about our technological development over the next 600 years. I think that would be quite a stretch of intent here. But I'm going to focus on a few things that I see as quite important over the years to come, starting with this word, robot. The mere word seems to invoke worlds of imagination. A robot. There's something scary about it. There's something really eerie and irritating about robot. Yeah. On the other hand, we've been fed with all these wonderful stories of science fiction universes to understand that perhaps there is a future in which we can work side by side with these creatures that may even look like us and behave like us and act like us in different ways. And of course, there's a lot of different dangers associated with that. Today, though, the majority of robots are really, really dangerous, in fact. They are deadly machines, and that's why they are bolted to the ground, shielded off by walls, because a welding robot that moves from one item to the next can easily chop off a head of a man if he stands in the wrong place. You don't want to go there. My interest in robotics is a little bit different. I want to focus on a special subset of robotics, namely the kind of robots that look like us. And so for the last couple of years, I've been working with the android DK, which is a copy of myself. I've been trying to understand and to explore in different ways what kind of situations could we end up in if we have robots like that. So by training, I am brought up in communication studies, and I studied information science. And I'm really interested in the way that we work with technology. And I do, in fact, envision a future where we can have a very close kind of relationship with machines that look like us, maybe to an astonishing degree. I call this the Android Society. By the time we get there, we'll have a different name for it, no doubt. But the Android Society is a societal condition in which people will work with robots, they will play with robots, they will live with robots even. And some of them might just look just like you. A couple of years ago, there was a journalist who rang me up and asked me, what is the most advanced android on the planet? And I was thinking a little bit and I said, I don't know. It could be you. I don't think that article was ever printed, though. But for obvious reasons. But we are actually in a position right now where we can build machines that resembles humans so much that in some extent it's quite difficult to see which is which. I've used the DK on a number of occasions as an examiner at an oral exam. That was fun, worked quite well, and the student passed his exam, went good. I've also used him as a university lecturer. That also went fairly well. Some of the students near the back didn't realize it was a robot until the break. And that has spawned a lot of really bad jokes about university teachers in Aalborg and mental capacities of students at the same place. For me, it's not really, I don't think that our students are worse off than most other students in the world, or that our teachers are much worse than anywhere else in the world. I think something else was happening. And what was happening was that the situation worked. And if the situation works and is about something, then we are very happy to embrace all these technologies that can give us different kinds of edges. But it may be in a not so distant future that when you apply for a job and go to an interview, it's a robot sitting there. Yeah. Or we can have situations where the division of labor is a little bit different than we know today. So humans will do one sort of chores and robots will do another kind of chores. Here, for instance, I could be on my way to another meeting somewhere in town while the robot is sitting there waiting, passing the time, until it gets time to pick up the kids from school. Would you trust the robot to pick up your kids from school? This is actually a question that you might have to come up with an answer to within just a decade or perhaps even less. This is feasible. Yeah. Or after hours, having a small drink and a cafe, wondering about what's been going on and where to go next. I do, in fact, envision this kind of future where you can work with a robot that will keep track of a lot of things for you. Maybe in the shape of something like a butler or a colleague. Because machines are really, really good at keeping track of stuff. Really good. So, while I tend to forget some of all the references we have to come up with for writing papers, the machines remember. Why not build machines that are able to associate between these things? So that you can actually have an active partner in doing research, in coming up with new ideas. Again, I think this might be possible within not too far from now. Then, of course, there is the matter of when we write these papers, what kind of names, and how do we put the authors on the paper? So this paper was co-authored by me and my robot. Does that make any sense? And since most of the monies for the university come by that way of production, we also need to think about that. So does a paper count in the accounts if it's co-authored by a robot? I don't know. Let's see if we can figure it out. So I do actually believe that the kind of machines that we will see will be, some of them, will be fairly human, they will be fairly adaptable to our environment, and they will be displaying true emotions and understanding what we are expressing with our faces and what our intentions are. There are some problems related to this, yes, but we're moving in that direction. We've done studies, for instance, where we have put me into stressful situations, making me very angry, very happy, very disgusted. One of my students, former students, had that tedious task of putting me in those situations. I think he kind of enjoys his work. And while doing so, filming my face and then replicating the expressions on my face and the face of the android, taking those pictures to people, trying to assess what is actually going on here, what kind of emotions can you recognize. And for at least some of the basic emotional displays on the human face, we get it quite right. And we have a fairly good understanding of what we need to do with the rest of the emotions for the future generations of androids. So what is actually on the horizon when we look into the big crystal ball? Let me point to three things. The first thing is that the future robots will be mobile to a great extent. And by now, we all have a fairly good understanding of what mobile technology can really do, because we all have it in our pockets. So we have a very deep understanding and a very deep sense of meaning attached to machines that are mobile and that will follow us around wherever we are. We're going to see that. Of course, this introduces a number of problems. One of them is that if you have a robot that can actually walk, problem number one is, where do I go? And that seems like a kind of a dumb question, but it's actually not. It requires a whole lot of planning and a whole lot of knowledge that is implicit in our minds, in our behavior. But we need to address that. Where do you go? Thing number two is that the future robots will be networked. Today, most robots are either stably attached to the floor, or at least they will be operated by a single computer. It can be an onboard computer, like a domestic robot that cleans the floor or something, or for industrial robots, it can be tethered to a computer machine. That is going to change. And we're going to see robots that are networked. And that means that they can do a lot of stuff that they can't do today. One of them is that they can talk to each other and gather sense information from many different places at one time. And the third aspect is that the future robots will be what we can call multiple intelligent. They will be able to draw on many different kinds of intelligent sources. Onboard computing, which is necessary for a number of reasons, but also a lot of other intelligence resources. For instance, let's return to the matter of where do I go, or how do I go? Please note that you can walk through university campus every day, walk down the street for extended periods of time without ever having to wonder who's going to give way to the other. So maybe 2 or 3 times a day, you're in that situation, you need to understand who's going where. How do we negotiate that? Most of the time, this is really automated. We just do that. But for a machine to learn this is a quite different scenario. We need to really think about how we do that. And one of the great potentials of today's technology is what we call big data, which is now available on a grand scale. So rather than making tedious programming on how to avoid obstacles and how to avoid bumping into things that are this size or this size or this size or this size, why not collect all that data from actual people solving the actual problem as they go down the street and feed that into machines and derive not just fixed algorithms but adaptive algorithms to solve these kind of problems. So the multiple intelligence issue is closely related, obvious, to the question of the network. How do we do this? I think we need a new kind of robotics. I think we need a kind of human-centered robotics. A robotics that puts the human in the center, not only for understanding what to do, but also for practical design. So let's take a little closer look at, again, some of the stuff that's actually on the horizon right now. And I like this picture here because it has 5 branches, like a hand. It's the power of 5. I really believe that today is a very, very good time for convergence. We see so much progress in so many different areas of science, and we need to pull them together. And here is an example of how this can be done. In the area of control systems, we will be moving away from just looking at how to automate a single process and moving into much more complicated issues, first in virtual reality, but definitely also in physical reality. And the power of the robot is really that it has a physical presence, rather than just these old, flat, boring screens that we've been used to looking at. So there are a number of challenges there, and people who work in automation and control, designing factories, today look very hard at what people do in the humanities, when they try to understand how do we keep from bumping into each other, and things like that. Here is another example. Learning from actual behavior, from actual people using their own bodies to solve actual problems is the way to go forward here. In the artificial world, or in the programmed world, there are a number of very nasty problems. In the beginning of computing, in the childhood of computing, it was thought that the language part of the way we interact with each other would be fairly easy to program because language is based on rules, right? And this became known as the language problem. And guess what? It is still a problem. And the reason for that is that although our languages are based on rules, communication at a higher level is based often on bending the rules or breaking the rules or not following the rules. And the way that we convey meaning is something entirely different from just being able to produce a syntactically correct structure. But again, using things like big data, we can feed these things into machines and let the machine learn on its own. And here's one of the most promising areas that I see. We see today a lot of progress in neuroscience, and we see a lot of interfacing between neuroscientists and roboticists. And what they're trying to do is actively connect the nervous system of animals and eventually humans with robots. Yeah. And that means that you can end up with machines that not only look like us on the exterior, but also on the inside is actually controlled by something that very closely resembles the human brain, which still is by far the most powerful entity that we have on this planet. It's right here. Not very well understood, but we are moving in that direction. And why start with animal neurons? We could actually use human neurons for that, which again is a little closer to home. A couple of years ago, colleagues in the UK made a series of experiments, including 25,000 brain cells from a rat in a petri dish. And that small amount of living tissue was trained as a bionet and was trained to avoid obstacles. It's not programmed, it's learning. the same way that the biological brain is learning. Another example, also with 25, 30,000 neurons from a rat, was trained to interact with the flight simulator and keeping the planes flying for extended periods of time. Yeah. So if you can do that with 25,000 cells from a rat, imagine what you can do with all the neurons in a room like this. Yeah. Now, obviously, this very small little stuff down there in the bottom of a petri dish has absolutely no idea about planes or Microsoft or falling down or whatever. It only does what it does good by nature. It reacts to the stimuli that's put into it. So why stop with animal neurons? We're learning much faster, much better that we can build things inspired by our own biology. And my friends in the business of building industrial robots say that trying to build something like a human hand and a human arm is still beyond us. We simply cannot do that. We don't have the technology for that because it's so versatile. It's an amazing tool. We can do things that are much more precise in certain levels. So that's fine. But having something that's this flexible is really, really a big, big challenge. But we are getting there. And again, the bridge to neuroscience is really important in prosthetics, for instance, and we see a lot of progress in that area. We also see new kinds of materials that can act both as sensors, but also as actuators. So very small, flexible pieces of material that at the same time can act like sensors. You can touch it, and it registers that touch. And also act as what is moving the robot. So a couple of years from now, you could actually walk into a lab like mine, meet the robot, and the robot will look at you and say, "Can I touch you?" Yeah. The big trick here is not to do all of these things separately because it's already being done. The big, big challenge is to put all these things together, to get them into one roof situation where these advances can merge together and we can have that kind of convergence that is really, really essential. It was going to be a big keyword for the years to come in technological development. Right. I do think that the future of robotics actually lies in us for those and a number of other reasons. But summing up, there is still a major issue that we need to look at, and that is this. When Mary Shelley wrote her famous book, Frankenstein, it's a beautiful romantic story. She opened up a world of thinking of our creations in a very specific way. Now, most people have a really poor understanding of this in the sense that they think that Frankenstein just created this ugly monster moving around like that. In the book, however, it's a very, very different situation. It is a sentient creature. It's a very sensitive creature that writes beautiful poetry. And all of his strive has one single aim. He wants the scientist to build him one more because he's so terribly alone. And he does not want to be alone. So we inherited the most human quality of all, our need to be closely connected to other people. So is that what we are doing? Some would suggest that we are in fact we are in the opposite situation, so it's actually us on the slab and the robots or the machines that are taking over. And perhaps this is also a scenario that we should be thinking about. My aim, though, is not that, but rather to be working together with the machines, because I do believe that together with robots and humans working side by side, we can harness the power of deep understanding of the human condition and of our technological surroundings that will take us way into the next 600 years. Thank you.